Hi everyone, my name is Ryan, I'm from AECOM. So today I'm going to talk about AI. AI sounds cool, AI sounds fascinating, but then the question is, are we ready for AI? So first of all, probably we need to talk about what AI is meant to do. So to me, AI is the intelligence shown by machines or software consisting or capable of doing tasks, solving problems, and making decisions by mimicking humans' intelligence. So in the area of geotechnical applications, AI could be, or the use of AI could be categorized into 4 groups. And here today, I'm going to focus on the first one, the use of AI to predict material properties. I'm going to use one work example to walk through the possible solutions and then share with you the observations that I made. And at the end of the talk, we'll come back to the questions, are we ready for AI? So first of all, data. Data, in this case, will compile from literature consisting of different soil properties of marine soil collected from various areas in South Korea. I aim to predict the soil compressibility, which normally requires more time to obtain, say for example, from your odometer test, from other simple and easy to obtain index and physical properties. So let's take a look at the plot. So in this case, you can see that some of the properties have stronger correlations with the soil compressibility. However, some don't. I adopt the Microsoft Machine Learning Studio as a platform to carry out the analysis. So the platform uses a drag and drop approach, which means no single command line is needed to build your own program. There are many built-in algorithms in this platform. It's like building your own Lego blocks, and you could choose whatever blocks or modules which you consider appropriate to build your program. 7% of the data were used as a training set, and 30% of the data were adopted as the validation set. Now let's have a quick scan of the results. Now it appears that the linear regressions and the Bayesian linear regressions outperform the others. On average, these 2 algorithms give about 20% discrepance. So here comes the questions that I want you to think about it. Is 20% discrepance acceptable to you? There's no standard answer. You have to make your own judgments as a geotechnical engineer. And that standard comments that I always being asked is, well, I can't explicitly see the predictive formulas. I don't like black box. And that's the reasons why I'm not going to trust the predictions. Now to me, and probably to most of us here, it's a fair comment. No one likes the black box. And the solution seems miss something, the physical meaning or the physical significance in which all we, the geotechnical engineers, were born to ask. So issue-like overfitting, issue-like outliners cannot be readily addressed with these machine learning programs. So to address that, probably you have to read my paper and get some hints on that. Coming to the concluding remarks. Now in the investment world, we often say cash is the king. Now in AI, I'll say it's not cash, but data. So the next questions would be, how are we going to share the data effectively? Now we are now in the digital era. So I expect more than sharing just a scanned copy or hard copies of the data. It should be something more. Besides, our geomechanics knowledge is probably the most powerful key to address the problem of black box, outliners, etc. and etc. AI is not everything and should not be everything. We, as a professional geotechnical engineers, have a role to play. Finally, collaborating with data scientists would be an excellent idea if we want to make steps further. So let's come back to the questions that we raised earlier on. Are we ready? Now probably we have to rephrase a bit the questions. It should be, are you ready? That concludes my GED talk. Thank you.